Cordially and affectionately welcome to a new documentary. If it is the first time, I introduce myself. I am the Engineer Hiddekel Morrison and I appreciate you decide to see this educational content, where we will know the scientific report that officially confirms the presence of a key ingredient of life on the planet Mars. Let's start this new educational adventure together. From the perspective of an engineer. Let's start. The robot rover Curiosity has made a great advance in the field of astrobiology by investigating the habitability of the planet Mars, studying its climate and geology. This robot from the United States Space Agency, NASA, extracted soil samples of a type of sedimentary rock called shale that is estimated to be 3.5 billion years old and is part of the formation of this ancient Martian bay where there was a lake and that today it is known as Gale Crater. This Martian rock formed as a very fine sediment, from physical and chemical weathering of volcanic rocks, in water that settled to the bottom of a lake and was buried. By analyzing the components of the extracted rock, NASA's Curiosity rover detected something that NASA scientists celebrate and have described as the key to life on Mars, a momentous discovery that we will detail below. But first, I ask you to support us by liking this video, sharing this video with your contacts, and subscribing to this channel, turning on notifications, so with your support, we can continue to frequently generate interesting documentaries on aerospace technology and the universe. Thank you for contributing to the creation of educational content. Basically, this place would have offered a habitable environment for life, if he was ever present. Jennifer Stern, NASA scientist, lead author of the research. With great joy, NASA published on June 27, 2022 this communication of great scientific value entitled, NASA's Curiosity takes inventory of the key ingredient of life on Mars, where they explain how organic carbon was definitely and conclusively confirmed, by multiple pathways, in rock samples taken from Mars. Explaining in the statement that in addition to liquid water and organic carbon, what they have been able to detect after years of analysis is that the Gale Crater had other conditions conducive to life, such as chemical energy sources, low acidity and other essential elements for biology, such as oxygen, nitrogen and sulfur. Highlighting textually that this place would have offered a habitable environment for life. Using data sent back from the planet Mars by NASA's Curiosity rover, scientists for the first time measured total organic carbon, a key component in the molecules of life, in Martian rocks. Total organic carbon is one of several measures, or indices, that help us understand how much material is available as feedstock for prebiotic chemistry and potentially biology, explaining that at least 200 to 273 parts per million organic carbon were found. This is comparable to or even more than the amount found in rocks in places with very little life on Earth, such as parts of the Atacama Desert in South America, and more than has been detected in meteorites from Mars. Organic carbon is carbon bonded to a hydrogen atom. It is the basis of organic molecules, which are created and used by all known life forms. However, organic carbon on Mars does not prove the existence of life there because it can also come from non-living sources, such as meteorites, volcanoes, or formed on the spot by surface reactions. Organic carbon has been found on Mars before, but previous measurements only produced information about particular compounds, or represented measurements that captured only a portion of the carbon in the rocks. The new measurement gives the total amount of organic carbon in these rocks, something that had not been detected before and which, due to the exposed characteristics, becomes a relevant discovery. Although the surface of Mars is inhospitable to life now, there is evidence that billions of years ago the climate was more like Earth's, with a thicker atmosphere and liquid water flowing into rivers and seas. Since liquid water is necessary for life as we understand it, scientists believe that Martian life, if it ever evolved, could have been supported by key ingredients like organic carbon, if it were present in sufficient quantity. To make the measurement, Curiosity delivered the sample to its Sample Analysis at Mars, SAM, instrument, where an oven heated the powdered rock to progressively higher temperatures. This experiment used oxygen and heat to convert organic carbon to carbon dioxide, CO2, the amount of which is measured to obtain the amount of organic carbon in rocks. Adding oxygen and heat allows the carbon molecules to break apart and react carbon with oxygen to produce CO2. Some of the carbon is locked up in the minerals, So the furnace heats the sample to very high temperatures to break down those minerals and release the carbon to convert to CO2. The experiment was conducted in 2014, but it took years of analysis to understand the data and put the results in context of other mission discoveries in this area called Gale Crater. The resource-intensive experiment was performed just once during Curiosity's 10 years on Mars. This process also allowed SAM to measure carbon isotope ratios, which helps to understand the carbon source. Isotopes are versions of an element with slightly different weights, masses, due to the presence of one or more extra neutrons in the center, nucleus, of their atoms. While the biology cannot be completely ruled out, the isotopes cannot be used to support a biological origin of this carbon either, because the range overlaps with igneous, volcanic, carbon and meteoritic organic material, which are most likely to be the source of this carbon. Organic carbon. That is why it is now much more key to achieve the sample return mission of the most modern rover, the Perseverance, to be able to have on planet Earth the rock and soil samples that the Perseverance rover is currently taking and to be able to analyze them in terrestrial laboratories. Its composition, in order to have the conclusion and definitive scientific proof of life, even if it was microscopically passed on the planet Mars. What do you think of the ever closer moment of confirming life on Mars? I read them in the comments of this video. As usual, we appreciate you informing us. It is a real pleasure to be able to provide you with the main news, trends and developments, about the most important aspects of aerospace technology and the universe, from the perspective of an engineer. I am the Engineer Hiddekel Morrison and I invite you to meet again in a future installment.